Hi, everyone, and welcome to our session on silviculture in Alberta's Boreal Forest. So my name is Brad Pino. I'm Associate Professor of Silviculture at the University of Alberta in the Department of Renewable Resources. I'd like to start with a quick land acknowledgement. The University of Alberta, its buildings, labs, and research stations are primarily located on the territory of Cree, Blackfoot, Métis, Stoney, Dene, Iroquois, Anishinaabe lands that are now part of Treaties 6, 7, and 8 and homeland of the Métis. The University of Alberta respects the sovereignty, lands, histories, languages, knowledge systems, and cultures of all First Nations, Métis, and Inuit. For a little bit of context, most of the work that I'm going to be talking about today from Alberta's Boreal Forest in the northern part of the province comes under what we refer to as Treaty 8. And broader Treaty 8 encompasses parts of northern Alberta, Saskatchewan, British Columbia, and Northwest Territories. And it was signed in 1899 between the British Crown, or Queen Victoria, and Indigenous groups residing in the area. So just a little bit of history of the area that we're going to be talking about here today. So what I want to focus on today in this talk on silviculture in the Alberta's Boreal, give you a little bit of an overview of forests of Canada and in Alberta. May or may not be familiar with this area, so I want to just briefly provide some of that. Give you an overview of silviculture in Alberta, and then provide 3 specific examples of what silviculture can and does look like in my part of the world. So I'll just mention that the focus here is going to be an operational silviculture. There will be some research component to this as well, but really it's going to be mostly about what is actually currently happening in silviculture here. Something to keep in mind, of course, is that any kind of overview like this, there's always going to be lots of examples that would differ or whatever. But in general, I think what I'm able to provide here is give you a kind of a snapshot of what silviculture looks like in Alberta as of today, and that being June 2026. Okay. First off, Canada is really a forest country, right? This is just the map of forests in Canada. I'm sure you've seen something similar to this before, but you can see, forests cover most of the country, and lots of different types of forests that we've got here. A few things to keep in mind here are that most industrial forestry that we have in Canada is happening on public lands. Okay, so most public lands in Canada are managed by the provinces, and in forestry, there's an extra step in there, which I'll talk about a little bit later. But one of the underlying premises of this is, sustained yield, which is reflected in the annual allowable cut. This is essentially making sure that we harvest at or below the rate of growth from our forest. And this is one of our really strong sustainability metrics that we have here. I think that's important to note here is that silviculture is generally as a requirement for companies to operate on public land. Silviculture is a requirement of being allowed to harvest. It's slightly done differently in different provinces, but in general, that is that's how it works. The other thing I'll note here is just based on the colors here, you can see the dark green is the boreal forest. And the dark green is kind of the more productive, what generally considered the commercial boreal forest. North of it is the kind of a lighter green there, and that would be a forest to tundra transition. So still forest, but not as productive. And then to the south, kind of above the yellow area, which is prairies, you can see that kind of, again, that transition, but instead of being a transition to tundra, transition to grasslands in the south. And again, the other thing that's important to note here is that most of Alberta's forests are boreal forests. So that's what we're really going to be talking about here today is silviculture in Alberta's boreal forest. Okay, main species that we've got here. The main species that we have in Alberta, and there's really honestly not that many of them, but we do have a few really important ones. But the 3 most important species that we've got here in Alberta are trembling aspen, lodgepole pine, and white spruce. So trembling aspen, picture on the left here, deciduous broadleaf tree. It's an early successional species. Tends to regenerate after disturbance, whether it's fire or harvesting or other disturbances. basically through vegetative suckering. So from the roots, new shoots come up afterwards. That's its general life cycle, but very kind of a disturbance adapted species. In the middle, we've got lodgepole pine. This is a shade intolerant early successional conifer. Its kind of unique life history trait is its shortness cones, and I'll talk about that a little bit later as one of our silvicultural examples here. And their final main species that we have here in terms of silviculture is white spruce, which is a late successional conifer. Now, these are the three most important species, and these run the vast majority of our forest industry here in Alberta. But there are a few other species that we've got. Other broadleaves, we've got balsam poplar, Papus balsamifera, and white birch. That's really it for broadleaves. Further south in the prairies, we do have a couple other populous species, but in terms of our forest area, that's really it. In terms of other pines, lodgepole pine is our most important one, but we've also, and it's also our provincial tree in case you're interested. There's also jack pine, which is a very similar species. And there's also a couple of five-needle pines, limber pine and whitebark pine in the mountain areas, but very rare. Similar species, we have Douglas fir a little bit in the mountains, but not really into the boreal, and tamarack, which tends to grow in wetlands in Alberta. In terms of spruce and similar species, white spruce is the dominant one, particularly on upland forests. But we also have black spruce, which is common in wetland areas, doesn't really make it into the uplands much in this part of the world. There's also true firs. We have balsam fir as well as subalpine fir that grow in Alberta. And that's it for tree species in Alberta. There really isn't that many. So why is this important? Just kind of give you a taste of what we're going to be talking about here in the boreal forest. In general, the boreal forest is characterized by being relatively cold, relatively dry forest, and not really that rich in tree species. And this is just an example of that here. Okay, so in terms of forest productivity, this is a map that I really like this map, so I show it to as many people as possible. This is an old map from Natural Resources Canada, and what it is forest productivity across Canada. And the way to interpret this map is the darker the colors, the more productive the forest is. And in general, you can see the darkest colors, so the reds and the purples there. That's on British Columbia coast, on the Pacific Northwest. That's by far our most productive forests in Canada. But within the boreal forest, which is kind of the northern band of forests, productive forest. The most productive boreal forest in Canada is in Alberta. Okay. And it's not because of our climate. We're relatively cold, relatively dry here. So, just as some general guideposts you could put in, on average, let's say around an annual temperature of around 3 degrees Celsius, so just above freezing on average throughout the year, and on average around, let's say, 600 millimeters of precipitation per year. As you go further east in the boreal forest, you get a lot more rain and other things like that. But the reason Alberta's boreal forest is so productive is because of its soil. So we're dealing with glacial soils. So give or take 10,000 years ago, we were under ice in this part of the world. As the glaciers receded, we were left with fine textured soils. So fine textured soils, think clay loams across much of our forests in northern Alberta, with high water holding capacity, so lots of water availability, and also they're not very leached soils, so there's lots of nutrients available to them. So our forests are really productive here, mainly because of our soils. This is something I think we have to kind of be thinking about, is that there's kind of some opportunities related to this, but there's also some challenges in the silviculture world. The opportunity is that if we want to grow things fast here, we can. We have very productive forests here. Even within Alberta, we have agricultural lands going quite far north, almost all the way up to the Northwest Territories border. Not quite, but almost. We have very productive sites here, and this is reflected in that. But there's also some challenges in that because we have really rich sites, really productive forests, we often have competition challenges. So after harvesting, there's an explosion of vegetation, of course, and this can result in a lot of competition challenges. We'll see where that kind of comes in a little bit later on and talk about some of the specifics about the silviculture treatments that we're dealing with here. But I think when I think about this is we have the potential in Alberta to do a whole bunch of different things because of our really productive forests. relative to the rest of the boreal forest. Okay. A little bit about wood processing in Alberta. We're a very industrial timber industry here. Lumber, pulp, oriented strand board, plywood, and a whole bunch of other stuff. Some of the largest pulp mills in the world are in Alberta, as well as some of the largest oriented strand board mills. In general, most of our mills are relatively new. We've had a large expansion of forestry after about 1990, where we're just being focused on conifers to incorporating other species, in particular aspen. About half of the solid wood products produced within Alberta are sold in Alberta for, building other things like that. The rest is exported. About 80% of our exports are going to the United States. In terms of harvest levels, so this would be the annual allowable cut, about 33 million cubic meters of timber per year. So this is our common metric that we use here of cubic meters for wood. So you hear that a few times out here. But that's divided about 2/3 into conifer, predominantly white spruce and lodgepole pine, and about 1/3 being broadleaf, predominantly aspen. So there's lots of other uses of our forest besides the timber industry, of course. We have a very active industrial land base with a lot of oil and gas development. Urban developments are happening, recreational developments are happening all over the place, and other kind of non-exploitive uses of the forest as well, whether recreation, other enjoyment of the forests, other values that we get from our forests. So in terms of forest management in Alberta, this is a map of Alberta, and the colors here are different forest management agreement areas. I mentioned before that our public land that we're dealing with here, right? So all the color areas is public land in Alberta. And each of the different colors is a different forest management agreement area. What this is an agreement between the provincial government and private industry, private companies, for the rights to timber in exchange for some responsibilities. Those responsibilities usually things like payment of stumpage to the province, operating a mill, harvesting timber, reforestation, the silviculture side of it, forest inventory, general forest management planning activities become the responsibility of companies, and the government's role is more of an oversight and rule setting rather than as an actual conductor of forestry activities. They do some, but for the most part, most of that is left up to the companies here. Other forest management responsibilities, kind of beyond the timber side of it, are generally still the responsibility of the provincial government. Things like wildlife management, fire management, that sort of stuff. That's still the responsibility of the provincial government, with input from and lots of involvement from the companies, of course. Most commercial forest land is also independently certified for sustainability, things like FSC and SFI. SFI is the most common. However, FSC is, if you look on the kind of the northeast part of the province, the big green area, that's the Alberta Pacific Forest Management Agreement area. It's about 6 million hectares. About 1/10 of the entire province of Alberta is included in that FMA. And just for a little bit of reference, that's about the same size as West Virginia. And that's the largest FSC certified land base in the world is here in Alberta. So that's a little bit on how forest management kind of works. But thing to keep in mind is that this is public land. We refer to it as crown land often, but it's managed for the benefit of all Albertans, right? So we often talk about sustainable forest management, but that includes the economic side, the social side, as well as the environmental or ecological side of this. So it's kind of the three pillars of sustainable forest management. And that's kind of the lens that we're working in here. So most of our forest management, most of our silviculture is done to meet all three of those objectives in some form or another, not just one of them. Okay, so what does silviculture look like in Alberta? Again, very industrial silviculture. So pretty standard kind of harvesting reforestation treatments, at least pretty standard in across much of Canada. But here's just couple figures on what silviculture, some of the trends in silviculture that we're seeing here. But we're in general, the blue line there on that top figure, that's harvest area. And what we've seen over the course of the past 30 years is approximately a doubling of harvest area in Alberta annually. So in 1990, there was harvested around 50,000 hectares. Around 2020, we are harvesting around 100,000 hectares per year. So really, that encompasses an expansion of our forest industry, but also some of it is also a reflection of increasing the productivity of our forest through silviculture. Most of the area that's harvested is planted. So that's that yellow line. It basically follows follows the blue line. Essentially, the way silviculture works, I'll talk about this a little bit more up ahead, but aspen and broadleaves generally regenerate on their own, natural regeneration, and conifers are generally planted. Other couple lines here. So the orange line is site preparation. We've seen a general decrease in site preparation over time. Well, there's been a more recent uptick last few years. And with herbicide, which is the gray line, what we see is an increase in herbicide in the late 1990s as it went from kind of a trial to an operational treatment, has maintained itself fairly high levels since then. But recently, in the last few years, we have seen a decrease in herbicide use to a lot of concerns from different groups about it. In terms of planting, we plant around 100 million seedlings per year in Alberta. Most of that, over 80%, is for the forest industry, for industrial forestry. And that's split evenly, currently about half between spruce and half between pine. If you look at the trends, and that's that bottom figure there, that's the species planted in Alberta on public land. You can see the orange is spruce, and what you can see is in 1990, most of the trees that were planted were spruce, and that kind of the spruce component has maintained itself over time. But what we've seen is an increase in planting of pine, not necessarily an increase in harvesting of pine, but we've seen a switch in pine regeneration methods from more natural regeneration to more planting of pine in recent years, and I expect that trend to continue. Okay, so harvesting in Alberta. Harvesting is an important part of all silvicultural systems, and generally what we see is mechanized industrial harvesting. So as of right now, we're still harvesting natural forests in Alberta. That's expected to start shifting towards managed forest or post-harvest forest in 15 to 20 years, depending on where you are in the province. But as of right now, we're predominantly harvesting kind of natural forests. So the harvesting process is kind of work through these pictures here, but it's mechanized harvesting. So feller bunchers, that's the top picture there. You can see a feller buncher harvesting aspen trees. So the trees are harvested, bunched together with the feller buncher, and then dragged to roadside by a grapple skidder. So our roads tend to function as our decking areas as well. The processing, so removal of tops, limbs, that sort of thing, happens at roadside. And then the result of that is large piles of brush piles, top piles, unmerchantable pieces, so large brush piles essentially. And what that happens is then they get burnt in over the winter time. So that's kind of our standard in timber harvesting scenarios. These are all essentially looking at clear-cut harvesting. The other thing that's important to mention here is that we tend to have some fairly long haul distances. We have some one-way haul distances of 400 kilometers or more, particularly with some of the pulp mills hauling aspen. We're hauling some very, very long distances. So what we actually have seen, one of the things that we've seen here is very large 10-axle log trucks are becoming common in some parts of the province. The other thing we've seen a kind of a change in harvesting over time is traditionally much of the timber harvest was concentrated in wintertime, and wintertime when the ground was frozen. There's frost in the ground, so the risk of compaction and things like that and soil damage are a lot less. But what we've seen is a trend now towards basically year-round harvesting. So what we see now is harvesting approximately 10 months of the year, a bit of a spring breakup time off. But for the most part, we're seeing harvesting essentially year-round happening in our forests now. Okay, so I mentioned this essentially, we're looking at clear-cut harvesting here, and I refer to these as silvicultural clear-cuts. And what I mean by that is these are examples of what some cut blocks in Alberta look like. Pretty standard cut blocks. There is trees left in them, unmerchantable trees, things like that. There's also requirements for leaving trees behind. usually about 3% of the volume in a cut block is required to be left standing. So that's one of the things that we see. There's also been some changes in cut block design. In the past, we had a lot of like square cut blocks. We actually refer to it as the checkerboard harvesting system of alternating cut and leaf patches in about 40 hectare squares or different sizes, but that get that idea of a checkerboard pattern. Now we're trying to incorporate more natural stand boundaries, more natural patterns, basing a lot on the natural disturbance regimes in the area, which is predominantly fire. But all of this stuff, whether it's the cut block design or leaf trees in the areas, these are really not done for silvicultural reasons for the most part. They're done for ecological reasons. So maybe it's for wildlife habitat, maybe it's for biodiversity benefits, other things like that. They're not really done for silvicultural reasons. And what I mean by that is they're not done to provide seed for the next crop. So it's not a seed tree system. Might look somewhat like it, but that's really not the purpose of it at all. They're also not there to provide any shelter. So it's not a shelter wood system. We are leaving trees behind there, but they are essentially, we're dealing with a clear-cut silvicultural system as the starting point for the vast majority of our industrial forestry here, for our forestry in Alberta. It doesn't mean that's the only thing we could do. But again, if you think about it in terms of sustainable forest management, this is the system that kind of best meets our economic requirements, our social requirements, as well as our environmental or ecological requirements for these sites. So this is the standard practice. Other silvicultural systems could work, but generally we're dealing with clear cuts here. Okay. So what does reforestation look like? As I mentioned before, reforestation is legally required on public lands. The general rule, and I'll be talking here about Alberta specifically, but in general it applies across much of the public forest lands in Canada, is the general rule is that reforestation is of whatever was harvested. So if you harvest a spruce stand, you replace it with a spruce stand. If you harvest an aspen stand, it gets reforested and becomes an aspen stand. Pine to pine, mixedwood to mixedwood. You get the idea. So that's our standard kind of silvicultural requirement. It's not exactly one-to-one like that, but in general, that's the spirit of the idea. Okay. Now, again, you might be thinking that some challenges here is we're taking essentially a clear-cut silvicultural system, which is good for growing early successional shade intolerant species, and we're potentially trying to grow late successional shade tolerant species like spruce, and this is where we can run into some challenges. But again, this is the system that we are dealing with here. So in general, we plant conifers, and natural regeneration of broadleaves. So again, aspen regenerates via suckers after harvesting, and the conifers are generally planted. So the conifers that we're planting, container stock, so grown in styro blocks. Nurseries generally 1-year-old stock is what gets planted. We're seeing a little bit more 2-year-old stock, but for the most part, we are seeing 1-year-old stock. And there's two kind of distinct stock types that we see here. They're much different sizes, but there's two general kind of stock types that we see, referred to as spring stock and summer stock. So spring stock is stock that's grown in the nursery and then overwintered in cold storage, and then planted immediately, frozen, and then outplanted in spring, usually in May and the early part of June, and then it's expected to flush and grow on that site that year. Okay, so that's referred to as spring stock. We also have what's referred to as hot planted or summer stock, and this is stuff that's grown in the greenhouse and then hardened off in the greenhouse and then outplanted immediately. So it doesn't go through a cold storage phase, but summer stock will be planted in July and August of the year. And generally, it won't flush this year. It might grow some roots and get it kind of adapted to the site, but it won't flush this year. And then it'll flush beginning in the spring next year. So those are our two main types of planting stock that we see here. Site preparation is quite common, and the general goal of most site preparation is alter the soil physical characteristics. In particular, the general plan is making a warmer, drier microsite. One of our challenges in the boreal forest is cold, wet soils. So after harvesting, we tend to see a water table rise, right? And in cold environments, water can really cool down the soil. So what we're doing with our site prep is often creating warmer, drier microsites. And the picture on the bottom there is of some mini mound. But you can see the mound that's created, and then you can see the spruce tree has been planted in the top of that mineral soil cap on there. So what we've done is we've created a raised microsite, which will be warmer and drier, and actually can extend the growing season for those trees quite a bit. There's a little bit of competition control treatment in there, a little bit of nutrient alteration as well, but most of the site prep is done for soil physical characteristics. So soil temperature and soil moisture, warmer, drier microsites. Most common site prep that we're seeing right now in Alberta is some form of mini mounding, such as the picture there. But there's other stuff that is common as well. Competition control is also quite common. Like I mentioned, being a really productive forest, our competition can be a big problem. And most common is still herbicide, in particular glyphosate. There has been a reduction in the last few years for a bunch of different reasons, but we have seen a reduction in it. But glyphosate is still the dominant form of competition control. It's usually applied, 2 to 3 years after reforestation, so after trees are planted. We don't really see much in terms of pre-planting site preparation herbicide use here, but it is common afterwards. Other things we're seeing are other types of competition control, things like brush saw and other treatments are being tried. We have examples of sheep grazing and other stuff as kind of trials right now, not being used very widespread, but we are trying out other things as well. And finally, monitoring. These are also kind of legislative requirements in terms of monitoring the forest after harvesting to ensure that it's being it's the right species composition as well as the right productivity rate of the forest. So there is some monitoring requirements, generally about after 8 years for establishment to make sure there's enough trees there of the right composition. And then we have a performance survey after about age 14, where we, as a performance looking at how well the forest is growing. Okay. So this is just a picture of an operational cut block in Alberta, post silviculture. So it kind of incorporates a lot of things I was talking about here. So this is an area would have been harvested in the winter, and then this is the next summer. You can see it was just planted. You can see the lodgepole pine tree planted in the middle there, and all of the broadleaves that are coming up, that's all aspen, and those would have all been regenerating naturally from root suckers. So the future of this forest is the goal is to have a predominantly conifer stand. So there'll likely be some sort of competition control treatment in this forest in the future as well. One of the things to note here is you can see there's a lot of woody debris on the ground. Again, we're harvesting natural forest, so our harvesting tends to have a lot of woody debris afterwards in our forest. Most of it is probably just from that and would have been there before harvest, but some of it is also in this picture in particular, is also from the harvesting and the brush piles that are created from the harvesting process itself. Okay, so that was a quick introduction to silviculture in Alberta. Now what I wanted to do is give you a little bit more detail on 3 what I find interesting examples of silvicultural systems that are being used here in Alberta. So one, talking about boreal mixed woods, scrotinus pines, and then also intensive plantation management. Okay, boreal mixed woods. So the term boreal mixed woods, what we mean by that is aspen spruce mixtures. There's lots of other potential combinations of different species growing in the boreal forest, but the term boreal mixed wood, what we mean is aspen and spruce growing together. Now, just think back here a little bit. Aspen, deciduous early successional broadleaf. Spruce, a late successional shade-tolerant conifer, right? So a standard or common stand structure we see here is aspen overtopping spruce. That's very common throughout our forests here. However, we get everything ranging from pure aspen to pure spruce and every mixture in between. And really what we see is those different those different stand compositions are just as much a successional stage as anything else. We tend to, after disturbance, so if you think of fire being our most dominant natural disturbance in the boreal forest, after fire, aspen becomes very common, right? And so we get a flush of aspen after the fire. And then spruce tends to seed in over time a lot more slowly. So start out kind of being aspen dominated, and then spruce kind of slowly growing up, surviving in the understory, growing up, eventually reaching the kind of a canopy. Then we'll have more of a mixedwood forest, and eventually the aspen dies out, and the spruce is much longer lived, able to continue growing, and then we'll eventually have a spruce dominated forest on the sites. But really, much of the differences in stand composition that we see are really different successional stages of that forest, particularly dealing with this in the natural forest. The silvicultural challenge comes in here in that generally what we're trying to do is recreate the stand composition that we had at time of harvest. So we're not trying to recreate necessarily the successional pathways here. We're trying to maintain those the species composition across the landscape. So if we're harvesting a mixedwood, the expectation is that growing a mixedwood, if we're harvesting a spruce stand, the expectation is it will be regenerated as a spruce stand, right? So in many ways, we're trying to bypass some of these successional stages to get to the desired stand type. So again, we can debate whether that's the right thing or the wrong thing to do, but that is kind of one of our metrics of sustainability, is replacing like for like in terms of maintaining that species composition in our forests. So the diagram that I have on here is from the McDonald chapter in the ecological silviculture case studies book that came out in 2024. But again, we were just dealing with boreal and mixedwoods as a potential example of what we could be looking at ecological silviculture. And you can't even see the details in that diagram, but what the point is there's lots of variation. You know, for everything from pure aspen to pure spruce, they're all mixed woods, and every kind of combination in between. There's lots of kind of spatial variation. So across the landscape, there's lots of variation in stand composition. And then within a stand, there's also lots of variation in the height, oftentimes with the aspen overtopping spruce. So in the diagram, kind of trying to demonstrate some of that variability, and then also provide some options for different silvicultural treatments, including harvesting, regeneration, and tending treatments. Let's quickly talk about harvesting boreal mixedwoods. And again, these pictures are from that same chapter. But what we've got here is we're still harvesting natural forest, and a lot of our natural forests have aspen overstory, spruce understory, right? So the term that we use for harvesting this, essentially, the idea is here you could go in and harvest the aspen, which is mature and merchantable, and then release the spruce in the future. So the term that we use to refer to this is understory protection harvesting. This is a very kind of Alberta or Western Canada specific term, but that's what we would call it. Another way to think about it is somewhat like a natural shelter would. So in many ways, what we're talking about here this is analogous to a removal cut of a shelter wood. It's just that we didn't have to do any kind of pre-treatments because the understory was already existing there, right? And just because the differences in shade tolerances and the odd ecology of these different species. But either way, what we get here is the style here is we tend to harvest in the equipment would go down in dedicated machine trails. That's kind of the part that gets completely cleared in the middle, and then you can reach it on either side of it to harvest the aspen. We also get these strips of aspen left, and those are a bit for a wind buffer. What we tend to see is that these strips are oriented perpendicular to the prevailing wind. So most of our winds across much of northern Alberta come out of the northwest, so these strips would be oriented perpendicular to that. The other thing we've seen is that blowdown tends to be worse, particularly for the spruce, when they're larger. So they tend to do better actually when the spruce are smaller. Some of the trees that less than about 9 meters tend to be a lot safer in terms of leaf trees than if the spruce are too tall and skinny, they tend to blow down a lot. But the goal after this is we'd harvest the aspen, the spruce would release, and then we'd be able to harvest the spruce and the residual aspen if it's still there in 40 years from now or something like that. I think the system can work. We used to see more of it. We're seeing a little bit less of it now, but it works well when there's kind of demand for aspen from mixed woods. Not the other option for these stands. The other option for stands with an aspen overstory, spruce understory is, in general, we have an abundance of aspen. But there's a demand for more spruce. So the other option is essentially just leave these kind of mixed wood stands, referred to as understory avoidance. Just leave those sorts of stands, let them naturally transition into a more pure spruce stand, and then when the spruce becomes merchantable, then it'll be harvested in the future, kind of foregoing some of that intermediate aspen volume. But this is what we're seeing across our landscape now for harvesting existing boreal mixed woods. Now the challenge, from my perspective, comes to how do we actually grow these stands if we want to have these in the future, and that's what we'll get to next. So growing boreal mixed woods. So in general, if mixed wood area gets harvested, the goal would be to regenerate it back to mixed wood. In the past, what we've seen is mixed woods have been harvested, and then what we've regenerated was essentially two single species stand. We regenerate part of the stand to being pure aspen, and part of it we regenerate to being pure spruce, and we would call that a mixed wood. So that might meet the definition of a mixed wood within a cut block, but it probably doesn't meet the spirit of what mixed woods really are. So now we're talking more and more about how do we grow intimate mixtures of spruce and aspen together. And this isn't that simple. It's quite, it can be quite challenging, particularly if we want to have a reasonable growth rate of the spruce. Spruce can survive in the understory of aspen, but it doesn't really grow all that well in the understory of aspen. So if we want spruce growth rates to be higher, we probably need to manage some of the aspen around it. So some of the things that we're seeing here is after harvest mixed wood, the aspen regenerate naturally from root suckers. Then what we're seeing is planting of spruce, right? So this might involve some site preparation, planting of spruce, but some sort of a regeneration treatment for spruce, probably some spot treatment as well around it. So we've seen examples of spot herbicides around planted trees, spot brush saw work as well. Maybe site preparation is enough to provide a bit of an establishment treatment for the spruce. That generally then would be followed up with some sort of a thinning treatment of the aspen, right? So aspen can regenerate at 100,000 stems plus per hectare after fire and after harvesting, and that's really, really dense. So once we get the spruce established, then thinning out the aspen and kind of providing more of the resources to the spruce is probably what's needed to grow these stands. Could be followed up with a commercial harvesting of aspen, and then again further releasing the spruce, or growing a mixed wood forward into the future. But regardless, the idea here is this is going to be a lot of work. So growing mixed woods will take a lot more planning compared to growing individual species stands, but it will require multiple entries to meet these objectives if this is what we want to do. And I think it is, and we're just starting to see more and more treatments being tested. How do we operationalize this? We have good examples of research projects which have looked at growing intimate mixtures of aspen and spruce, and we're just starting to see some of that being implemented in our more operational silviculture now as well. So that's an example of growing aspen, spruce, and boreal mixed woods. Next example I want to talk about is scrotinus pines. So this is lodgepole and jack pine. And what scrotinus is this is where the cones are essentially glued shut, and then they open from the heat of a fire. So naturally very fire adapted species. So in Alberta, we have lodgepole pine in the western half of the province, jack pine is in the eastern half of the province, and then there's a hybrid zone in the middle. But they're very, very similar species, shade intolerant, early successional species. Both scrotinus and very fire adapted because of that. So they naturally open after fire. So silviculturally, look at ways, how can we kind of incorporate that into our silvicultural system? So with the scrotinus pines, we essentially have an aerial seed bank. Could be up to 20 years, probably generally not that much, but it could be up to 20 years of cones and seed that are stored in those trees every year. So they don't get released every year. That it's stored in the canopy of these trees. After the fire, the heat would release the glue, the seeds would come out, and we get a new forest, right? After harvesting, we don't necessarily get that, but we can emulate some of those processes and still get a lot of natural regeneration. And what we do is referred to as drag scarification. And the equipment, the site preparation is in that middle picture there. And those are referred to as shark fin barrels. You can see the barrels with the shark fins on them, and then anchor chains. And what we get here is the The anchor chains kind of spread the slash around, put the cones close to the ground. The shark fin barrels kind of rotate like that through the as they're being pulled behind a skidder. And what they do is, as they're rotating, they scalp off some of the organic material and expose the mineral soil. In the heat of the summer, the mineral soil heats up, hot enough to actually melt the glue, so over 50 degrees Celsius, melts the glue holding the cone shut. Seeds are released. We get natural regeneration here. So it works particularly well on poor sandy sites, is where we see this a lot. One of the things we get actually after this is when it works well, it works very well. And we get very high regeneration rates. So it's often followed up with some sort of pre-commercial thinning afterwards. So this is an aerial view of a skidder pulling the drag chains. From behind it, you can see the kind of the linear patterns it's making. It's kind of spreading the slash around. So we used to see a lot more of this, and we used to see a lot more drag certification for regenerating a pine. As I showed earlier, we're actually planting a lot more pine now than we were previously. So it's still common, but not as common as it was before. And there's a few reasons for that. One is that it creates a more variable regenerating forest, quite patchy, which may or may not be desirable from a forest management perspective. Also results in high density stands, which then often need a follow-up treatment. So you have to go in and do a pre-commercial thinning afterwards. Planting, you can actually control the density more right from the start. The other thing is we also have a very active tree improvement program in Alberta for both white spruce and for lodgepole pine. But if we're always relying on natural regeneration, then we're not able to use our more advanced tree genetics. So we can't use the best possible trees. We want to get them out on the in the landscape as well. So all this kind of resulted in we're seeing more and more planting of what traditionally would have been drag certification blocks, but we're now planting them. This is still happening, but not as much as it was in the past. The other thing I'll mention about this is that it is a we're trying to emulate some of the incorporate some of the natural processes in our forest, right? So that's part of this. There's also a made in Alberta kind of silvicultural system, which Scrotinus pines are relatively rare, but there are main pines that we have here. And this system really works with the Scrotinus aerial seed bank, can spread the cones out across the site, can result in the high soil temperatures to melt the glue holding the cones together, release the seed, get lots of natural regeneration. But the system was developed in Alberta, although it's widely used in Scrotinus pines and other places as well now. But it's kind of a neat little Alberta silviculture story. Okay, so the final example I want to give is about intensive conifer management. So it's mostly focused on white spruce, lodgepole pine, and it's for saw log production. So what we see is most of our intensive management as in other places, but we're really focusing on saw log production. This is becoming more common in Alberta. One of the things that I hear, and I think I want to get this idea out of people's heads, is that trees have to grow slow in the boreal forest. Well, they don't have to. They often do, but there's also a lot that we can do, and we can actually get some really good growth rates. And what we've seen with some of the more intensive management is kind of a 2 to 4 times increase in the productivity of our forests relative to natural forests. Many of our natural forests are in the range of 2 to 2.5 meters cubed per hectare per year of mean annual increment, or MAI. MAIs of up to 8 have been seen in a lot of different examples of more intensive management for white spruce plantations in Alberta. So quite a lot more production from this. So it is possible. Okay. Some of the other benefits of doing this, kind of going down that idea of if we're doing more productive management in parts of landscape, we can do more ecological silviculture or silviculture for other benefits in other areas. Maybe it's areas that are being left for wildlife habitat or things like that, more parks and protected areas, whatever it might be. The other thing that we're seeing is we are an industrial landscape here, and we're losing land every year for industrial development, oil and gas in particular, but also other things, whether it's urban developments or recreational developments or parks and protected areas. We are losing forest land base from the timber side of it every year. So what that means, if we want to maintain that kind of that productivity from our forest as a whole, we need to increase the growth of our remaining forest, and this is one way of doing that. The other thing that we're seeing is there's a lot of overlap between intensive management practices in particular thinning, and other kind of adaptation practices, so resiliency type silviculture. So if you think about thinning, essentially what we're seeing is thinning can be done to increase the growth of residual trees. You can get them merchantable sooner. But what it also does is it provides a bit of relief from drought, is trees and thin stands, which have less competition, tend to be able to survive and grow through droughts better. So kind of this overlap of management objectives between timber as well as climate adaptation. So why do we do intensive silviculture? The short answer is because it works. So there's just a couple of pictures. These are tree cores that I have in my lab, and I just really like them, so I like showing people them. But the top one is white spruce. On the left, we have the natural origin stand, diameter about 37 centimeters, and it was 165 years old. That's a nice big tree, right? The one beside it, that's from an intensively managed plantation, diameter about 35 centimeters, and it's 24 years old, right? So similar size, very, very different age, 165 years, 24 years. Now, this is a bit of an extreme example, but I'm using it to illustrate this point is we can grow trees fast here if we want to. Okay, on the bottom is lodgepole pine. The bigger one that had been thin. This is actually from the bottom one, lodgepole pine, is from a trial, so that's from the same stand. So the site conditions are exactly the same. But anyways, the one on the bottom was pre-commercially thinned. It's now age 40, diameter of 34 centimeters. The other one there, the smaller one, is the unthinned control, and it's a diameter of 19 centimeters at age 40. So quite a big difference. So we can grow trees a lot faster. The other one, bit of interest there is the larger lodgepole pine there. You can see the stain on the blue stain on there. That's from the mountain pine beetle. And this down was actually just commercially thinned as well. Now, so, but the point here is that intensive silviculture can and does work in the boreal forest, and Alberta is, somewhat uniquely placed to take advantage of that because of our good soils. So quickly just run through what this looks like in a white spruce plantation. So white spruce plantation starts with site preparation, initial planting, usually around 2,000 stems per hectare. That's higher. Our kind of operational standard is more like around 1,600. But if we're going for more plantation management, generally higher densities are being planted simply because we know we're going to need, if we're going to be doing commercial thinning later on. But anyways, this is the standard for this, usually using the best available tree seedlings, right? Competition control. After that, usually one, perhaps more competition control treatments if needed, but basically just so that all the resources on these sites are going to the trees. What we're seeing now is commercial thinning, so an operational commercial thinning or CT at age 25 to 35, depending on the individual stand, but then down to about 800 stems per hectare at that time. So in general, these are trail-based thinnings. You can see on the bottom there, that's a harvester. So we're using harvester forwarder scenarios for these rather than feller bunchers. But this is only the last 5 years or so that we've been seeing this in Alberta. And what they're looking at here is kind of trail-based thinning. So about every 7th row of trees is an extraction trail, and then the harvester can reach into the next 3 rows over to extract trees from the surrounding matrix. And what we see is about half the volume that gets removed comes from the trails, about half the volume is coming from the matrix, but down to about 800 stems per hectare at that first commercial thinning. And this sets the stand up for either a second commercial thinning 10 to 15 years later, or a final felling at age 40 to 50. So our natural forest, we often think of a rotation age of about 80 to 100 years or even longer. What we're talking about now for intensively managed plantations is we're looking at rotation ages of 40 to 50 years. So about half of the age of natural forest. So that's what this could look like. And so now I think there's a huge potential. I think there's a huge potential for intensive management in Alberta. I think it's a great way of meeting our wood production goals, as well as then allowing a lot of other treatments to happen across the landscape to meet other objectives as well. So for me, the question isn't, can we do this? To me, the answer is clearly yes. We've done lots of research, there's lots of operational examples of this, that intensive management can work in the boreal forest. Now the question is, where do we want this? Where are the best sites? Where do we not want this? Where are these two at risk from fire or other disturbances that we might not want to do this? But where do we want this and how much do we want this? I don't think this is something we would want necessarily across our entire forest landscape, but where do we want it on the landscape and how much of this do we want on the landscape are now really the questions that we have to answer about more intensive management. So I just wanted to give you guys, 3 examples of silviculture in Alberta. So boreal mixedwoods, then serotinous pines, and finally conifer plantations. So thank you very much. Give me an opportunity to talk to you about silviculture in my part of the world being, Boreal, Alberta. Thanks very much.